The information contained in the course is based on the content of the Transit Connect Electric Owner's Guide supplement. This may be found in the glove box of your vehicle and is also available electronically in the technical library area of AZDtec.com. When you have completed this instruction, you will be able to explain the basic operation of the electric drivetrain and identify the major components, describe the unique components used for operation of the braking, steering, heating, and air conditioning systems, locate major components and service items under the hood, explain the electric system indications on the instrument panel, list the correct procedures to follow for starting vehicle operation, explain how to initiate regenerative braking, and describe the use of the shift lever for manual selection, list desirable practices to follow for ensuring maximum range, demonstrate the recommended procedure for vehicle parking and shutdown, list the steps for charging the vehicle, and describe the methods of maximizing charging effectiveness. The Transit Connect Electric is based on a chassis from Ford Motor Company, which is prepared with most major chassis items and operational systems, but with no source of propulsion. Azure Dynamics adds a complete high-voltage battery-driven electric drivetrain and other components to serve operational systems which need a source of vacuum, electrical power, or hydraulic power. The basic electrical drivetrain consists of a high-voltage battery, an electric traction motor and controls, a gearbox, and drive shafts to power the front wheels of the vehicle. The powerful electric drive motor is both a motor and a generator. In normal driving operation, the motor receives power from the high-voltage battery and drives the front wheels through the gearbox and drive shafts. When the vehicle is slowing down, the front wheels turn the motor, which is electrically switched into operation as a generator. The drag created by the rotation of the generator by the wheels is called regenerative braking, similar to the engine braking found in a conventional vehicle. Along with assisting to slow the vehicle and minimize the use of the vehicle brakes, this also serves to send high voltage back into the high voltage battery. The steering system on the vehicle is similar to that of a conventional vehicle. It uses the standard power steering rack assembly and mechanical steering components, but uses an electro-hydraulic pump to provide pressure to the power steering rack. The braking system of the vehicle is also similar to that of a conventional vehicle, but uses an electrically driven vacuum pump to provide vacuum to the power brake booster. Since there is no internal combustion engine to provide a source of heated coolant, the Transit Connect Electric has an electrical coolant heater mounted on the front of the traction assembly under the hood, which provides the source for cabin heating. While the high voltage battery, or ESS, is located under the rear cargo area of the vehicle, and there is cabling and cooling lines running below the floor pan, most of the components are housed in the forward part of the vehicle or under the hood. Using the ignition key to unlatch and open the hood, you have access to view the major components and service items. As shown here, you will find 1. The reservoir for the electronics cooling system, 2. The reservoir for the cabin heater coolant, 3. The high voltage charger on the back of the traction motor, 4. The brake fluid reservoir, 5. The 12-volt battery, 6. The vehicle control unit, or VCU, 7. The reservoir for the power steering fluid, 8. The cabin heater unit, 9. The traction motor inverter, and below it, 10. The traction motor. Information on these underhood components and procedures for checking and filling fluids are found in the Owner's Guide supplement. The instrument panel indications are different than in the standard Transit Connect. On the left side, a large range gauge is shown, which indicates the approximate number of miles that can be traveled on the existing state of charge for the high voltage battery. Arranged on the face of the range gauge is a series of icons which are warning lights for various vehicle functions. Operation of these is shown in the owner's guide supplement. To the right of the range gauge is a temperature gauge. This indicates the temperature of the cooling system, which regulates the temperature of the major electrical drivetrain components. On the right side of the instrument cluster, you'll find the speedometer and another set of icons which serve as warning lights for other functions. These are also shown in the owner's guide supplement. To the left of the speedometer, you'll find the high voltage battery state of charge indicator. This indicates high voltage battery voltage. The operation of the vehicle is initiated by using the ignition key. The key has 4 positions: off, accessory, on, and start. The on position is the normal driving mode and is also used when the vehicle is on the external charger to allow the use of the environmental systems as necessary. The start position is what initiates the high voltage system for driving operation. Starting the vehicle involves inserting the key, turning to the on position, and then to start. As the vehicle high voltage system is initialized, the range gauge moves up from 0 to indicate approximate range, and the state of charge indicator moves to show the current state of charge. The vehicle is now ready for normal operation. To drive the vehicle, depress the brake pedal, shift out of park into either drive or reverse, release the parking brake, and apply pressure to the accelerator pedal. Driving the vehicle requires no special techniques. With the vehicle in the D position, the vehicle will move forward and speed will be proportional to the amount of accelerator pedal movement. Along with the lack of engine sound and unique sounds of the traction motor, the only difference which will be apparent to you in driving the vehicle will be that there is no gear shifting. The gearbox in the Transit Connect Electric is a simple, single-speed unit which provides needed gear reduction and differential action to allow the front wheels to turn at different speeds as you go around corners. Movement of the gear selector control in the Transit Connect Electric into the 1 or 2 positions does not provide any change in gearing or acceleration. Normally you are operating with the selector in the D position. When you lift your foot from the accelerator and make any brake application, the VCU will signal to create regenerative braking by creating driveline drag from the generator mode of the traction motor. If you move the gear selector out of the D position into either 2 or 1, there is a change in the signal sent to the VCU. When you are descending a hill or simply want more regenerative braking, you can move the gear selector down to the 2 or 1 position and command more regenerative braking and high voltage battery charging. This will not only minimize the use of the vehicle brakes, but will contribute to vehicle range by sending more charging voltage to the high voltage battery. The Transit Connect Electric is an all-electric vehicle powered by the high voltage battery. Some vehicle systems like air conditioning and the cabin heater system use high voltage as well. This means that vehicle range is affected by not only driving the vehicle, but by consumption of power from these high voltage systems as well. 12-volt systems on the vehicle include the expected lights, wipers, horn, heater and cooling blower, and electric radiator fans. Specialized 12-volt equipment includes this power steering pump and vacuum pump. All 12-volt items which are in operation and consuming power will take power from the 12-volt battery. This is automatically charged with a special DC to DC converter on the vehicle, which is powered by the high voltage battery. So, Maximum range for vehicle operation can be ensured by minimizing the voluntary use of 12-volt systems unless they are needed for safe operation. In addition, light acceleration and moderate vehicle speeds will minimize the rate of discharge of the high-voltage battery. Whenever you stop and are going to park and leave the vehicle, you should follow the procedure suggested in the Owner's Guide supplement. First, pull up and engage the parking brake. After moving the gear selector to park, turn the ignition key to the off position and remove the key from the switch. At the end of the daily drive cycle, you will want to allow the vehicle to be charged. After removing the key from the ignition, walk to the right rear side of the vehicle and use the key to unlock the charge port door. This is the same door that is used as a fuel filler door on a conventional Transit Connect. After opening the door, release the catch to allow the charge port cap to open. Now, plug the charger plug into the charge port receptacle and note the click as proper engagement is made. With the charging station activated and plugged into the vehicle, you will note a flashing green LED lamp that indicates that the vehicle is charging. The amount of time needed for a full charge will vary depending on the charging unit and the amount of discharge present in your vehicle high-voltage battery. In general, you will need 8 to 12 hours for a full charge with a level 2 charging station operating on 208 to 240 volts. As noted in the Owner's Guide supplement, a red LED is provided as a warning for a charging malfunction. In addition, certain restrictions apply to charging under extreme cold weather conditions. If needed, the vehicle environmental systems with heating or cooling can be run during the charging cycle to ensure that the vehicle cabin is kept at a comfortable temperature. This preconditioning can be accommodated by returning to the cabin, inserting the ignition key to the on position, and using the appropriate heating or cooling device. This should be discouraged under all but extreme conditions, since it will significantly lengthen the amount of time needed for high-voltage battery charging. This concludes the presentation portion of this course. There is currently no examination given for course completion. If you would like additional information on the vehicle, please go to the AZDtec product support website at www.AZDtec.com. Thank you.